Good morning, friends. Today, in our next session of radiation, we will discuss net radiation heat exchange from a surface. If we have any surface, then how much heat is exchanged from that surface, that we will derive in this theory. We already use some equations of conduction and convection. Same way, we will derived equation for radiation. Now for that, we already discussed few definitions like irradiation. What is irradiation? It is capital G. And it represent the total radiant energy received per unit time, per unit area from all direction and wavelength. It is irradiation, capital G. Now next definition is radiosity, J. So what is radiosity, J? It is total amount of energy emitted from a surface per unit time, per unit area. It is radiosity J. And radiosity J include reflection and emitted energy both. Now from definition we can say that this is the emission or emitted energy, and we know that the energy reflected is irradiation plus reflectivity. The all energy received from all direction and all wavelength multiplied by reflectivity, it is energy reflected from any surface. Now summation of both is radiosity J, and we all know that the emissive powers equation is epsilon into EB, where epsilon is emissivity of surface. Now consider a gray body in which heat is transferred or through radiation, and this is the total energy from a surface. And net energy leaving is Q upon A J minus G. It is equation number 1. And this is the gray body. Now net heat leaving from this is J minus G. G is total radiation received, and J is emission plus reflection. So net energy leaving is Q upon A J minus G. Now we know the equation of three properties: reflectivity, absorptivity, transmissivity, all is 1. And for opaque body, we are considering opaque body, so tau is 0, and for gray body, epsilon is equal to alpha. So putting this in equation number 2, we get alpha rho plus epsilon plus 0 is equal to 1, and if we put rho as a subject, then we get rho is equal to 1 minus epsilon. Now we already discussed this equation. It is J rho G plus epsilon sigma EB. In this, put rho is equal to 1 minus epsilon. So making G as a subject, we get J minus epsilon EB upon 1 minus epsilon. And we derived equation of G. Put this equation in our previous equation. So we get Q upon A G minus J minus G. Instead of G, we are putting J minus epsilon EB and 1 minus epsilon that we derived in this. Now solving this equation, we get epsilon in the bracket EB minus J upon 1 minus epsilon, and in terms of our equation of conduction and convection, we can write our equation like this: Q is equal to EB minus J upon 1 minus epsilon upon epsilon A. So this is the net energy is exchanged through radiation from a surface. In next lecture, we will discuss same equation in electrical analogy, and then we will discuss a new topic, how heat is exchanged from one surface to another surface. Okay, thank you.